Yeah. Okay, so we could just do our thing. All right, so here we go. So we are on page 158. Right? And it's U-Substitution, which we're about to learn. We're gonna start with the easy ones, yeah? Okay, so remember like when you had like y equals, let's say, 5x plus 2 squared, and you went to take the derivative, what was the issue? What did you have to use? The chain rule, right? So there's something, so you would get 5x plus 2 to the first multiplied by 5. Yeah? All right, so just like there's the chain rule for this, chain rule. Okay, so for integrals, there's something similar. So if you take a look on this page, the first one, and again, we'll scale it up as we go along, but you see this binomial in raised to a power. Now you can't just do 3x minus 2 to the 5th over 5, right? Because that would not account for that 3 sitting there, especially right knowing that. Okay, so what you do is you make a U-substitution. So typically it's in the more complicated expression, it's within the more complicated expression, meaning you wouldn't want to make, in this case, U 3x minus 2 to the 4th, because if you did, what would du dx be? What would the derivative be? Right, it would be 3x minus 2 to the 3rd multiplied by 3 multiplied by 3. Okay, and then that would be like, there's nothing there that you could substitute. It just made life more complicated. Okay, so what you do is you do U is equal to 3x minus 2. By doing that, right? Okay. So now tell me what du dx is. 3. Okay. Is 3. So du dx is 3. So you're gonna see me in a second go from this to always just writing it as du equal to 3 dx. You see how it's like I can just cross multiply there? Now the reason why we want to do that is because everything here wants to be replaced with something here. Okay, so right now, so everything in here needs to be replaced with something down here. So for instance, the 3x minus 2 is our u. That's looking good. And we need dx to be replaced with something. So again, you can, hold on. You can, like my suggestion would be, is to make this a third du equals dx, meaning just divide by 3 on that side, because I'm going to then replace dx with a third du. Because you want to have the integral as u du now. You can't have it as u dx, it has to be u du, it has to be the same variable. The only issue, or not really issue, is that you have the third. The third I bring out to the front, right? The constant I bring out to the front. Okay, this is now u. So that's u. So it's u to the 4th. And then dx was a third, which I put here. The third. Only constants can come out, not variables. And then dx becomes what? D. All right, and now we could start the problem. Oh. Right, so from here, it becomes 1/3, and what's the integral now? Right, u to the 5th over 5. Remember the plus c.
And you just replace u.
Right, so 1/15. The u is 3x minus 2 to the 5th plus. Not so bad? Okay, all right, so again, we started small. I want to definitely build up, but before we do that, let me just have you try one on your own. Yeah? Okay. So let's try number. Good? Okay, so number 3. Number 3 is the integral of 4, 6x minus 1 to 2/3 dx. So again, I suggest taking out the constant first. But you don't have to, right?
I don't know.
You don't want to? No. Okay.
Then I couldn't let you get it.
Okay, it's fine.
That would be pretty bad. Especially today, I would think. Let's see if the lighting's better.
I think it's okay. I'm gonna take out 4, but then I'm gonna leave you to do your own thing. So whenever you're ready, let me know what you set U to be. And again, you don't want to make it so that the derivative becomes more complicated, right? I showed the video before during class of the derivatives, the derivative trick. I mean, Abby was here to see it, but Natalia and Gitty, do you want me to show it again? Would that help you remember? Because again, we like remember that little trick that we learned with like secant tangent. No. You want to watch? Well, we can watch it quickly. It's like 2 minutes. It's like 2 minutes. Yeah. Oh, you remember it?
Yeah.
Oh, okay. So perfect. Okay. Yeah. Right. So because we're gonna go backwards and the sign's just gonna switch. Yeah. But the sign's just gonna switch because they're integrals. Right. Okay. All right. So what do we let U be here? Okay, good. So U equals 6x minus 1. And therefore, du, now notice I don't do du dx. I'm already gonna bring the dx to the other side, is gonna be what? Right, 6dx. Now remember, I want to replace the dx. So I'm going to divide out here or just make it a 6 du, right? So a 6 du equals dx. So I'm going to have the 4 on the outside, the 1/6 on the outside, integral of u to the 2/3, and then the dx gets replaced with the du. Good. Okay, so let me just make a little, that kind of looks ran into. Good. Okay, so now we just take the integral. So what'd you get, Kitty?
Well, I kept 4.
Oh, that's fine. That's fine.
So then I got 8/18 u.
Okay, so I'm gonna just do u to the, you had 8 over. Oh, okay, because you had, yeah, and then you pulled it out after? So hold on 1 second. You left the 4 in. So hold on. If you left the 4 in, let's just go with what you did. Okay, so then inside here, you got what?
So then I got 4 times 2 over, wait.
Well, so, like when you,
Okay, 1 second.
okay,
Just 'cause-
I'm just trying to get all the steps written out.
Yeah, I see. Hold on. Yeah. So, okay, I had 1/6. Mine's
Okay, so I have the 1/6 here. Go ahead.
6 then you get U to 5 over 3
Right.
over,
That's a big exponent, wowzers. Okay, 5/3 multiplied by 3/5, right? Because we need to divide by, okay, okay, so multiplied by 3/5. Okay. And then, yeah, no,
no, I just did it differently.
Okay.
Sometimes.
okay, plus your C. Because we did a U to the 5/3, right, over 5/3, which became 3/5. Okay, and then when we clean it up, I was just gonna do this, and so this goes twice, this, and so this goes twice, so I got 2/5. Right, so 2/5, and then U,
6x.
6x minus 1, 6x minus 1 to the 5/3 plus 6.
I got 12 over 3.
Oh, so you just didn't reduce it?
Yeah.
Okay, perfect.
No.
You good? Okay, so now let's try. They're not so bad. It's not so bad, right?
No, it's just weird.
Right. It's a little, again, like you have to put your thinking cap on. And it's just applying it. All right, let's look at number 5. Yeah, no, not yet. I figured. Take it slow. Now, remember, you cannot pull out a, right, so you don't want to do that. You want your U to be something where when you take a derivative, there's something else there to replace. That's why it's called U-substitution, right? You want there to be some kind of substitution. So what do we think we should let her?
Multiplication.
Right. That's okay. The other ones are multiplication, like 4 times something, right? Okay, so go ahead. What'd you say?
You get rid of the square root and you put that half.
Okay, so you could definitely do that, yeah. Okay, let's just, okay, that's fine. Okay, so let's just do that to the 1/2, okay. And then what did you let your U be?
It was 1 minus 4.
Good. And then you didn't do this to the 1/2 because it becomes more complicated, correct? Okay. And then, whoops, sorry.
I split it into 2. So I did like the integral x squared plus the integral.
Well, you can't because these are multiplied.
Oh, no.
Right, those are multiplied, right? So there's no, with addition and subtraction, right? Not multiplication, yeah. We can't take, in other words, the integral of something multiplied isn't the product of their separate integrals, right? Whereas it is with the sum and the difference, yeah. Okay, so now, what is du? Good. Okay, which is good because here there are x squared, right? So what we'll do is, right, you left are you leaving the -12 in? I just always take it out in the front here.
I always leave it in.
Oh, you leave it in, that's fine. You take it out, okay. Again, everyone has their own kind of way for doing this. I just kind of like it to be out there, so this becomes like minimal for me. So then x squared dx is du. Okay, sorry. So, x squared dx gets replaced by -1/12 du. And then this is my,
Why do you take out the x? Oh, x squared, got it.
the x squared is not taken out yet, meaning the x squared
I see.
got absorbed by the du, right? This and this are the du. This is my u to the 1/2. Right, you see how you're making, it's like making a puzzle, right? The puzzle pieces.
Because x squared times dx is equal to -1/12 du. You could just now ignore them and replace it with 1/12 du.
Right, meaning x squared dx, since it's equal to this, you could substitute x squared dx by negative 112 du. So our goal is to get like an expression with u du. Okay. Yeah. Yeah. Okay. So then let's bring this down. That far. So negative 112 u to the goes to the half, so it becomes 3/2 over 2. Right. Multiply by 2/3. We're okay with that?
Yeah.
Okay, 2/3 plus c. And then we fix this up. So negative 118. My u was 1 minus 4x cubed. 1 minus 4x cubed. So 3/2 plus. Good so far? All right, let's do, I know you spotted 6, so let's do 6. See, either 6 or 7 are very similar. Then we'll do a trig, and then I'll go back to one that is a little bit more interesting. These are very interesting, I'm saying, but I'm just, have a little bit more of that to them. All right, so this is good. So let's try number 6. Number 6, so the integral of x over 2x squared minus 1. I'm gonna already put it to the 1/3. Is that okay?
Yeah.
All right. So do you want to try it on your own? And see what you got.
This is your shot. That's universal.
That's so
The cutest.
Do you like draw something and follow this?
I always, when I go on vacation, I always send her tons of pictures also.
Really?
Like one time there was like where I went to, I was in California, but I was in
What do you do
the,
when you go to?
oh my gosh, we do everything. We visit all like,
Everything?
we visit all like
Where do you
the,
go, like LA?
we went to LA last time, and then we go to San Diego, we go to the zoo, we go to Universal, we go to,
My stepfamily's from.
yeah.
The zoo, I think.
Yeah, the zoo, I mean, then there's obviously Disneyland, which we used to take the kids to.
Right.
And then, but we also visit all the scenic spots where they did, like this year we're going again. And we're staying across from the house where they filmed Three's Company. I don't even know if you know what that is,
No,
yeah.
But that's very cool.
Right, and we visited, like, there's an old, very popular, show, where they have a firehouse, so we visited that. So, yeah, we visited from the kids, Piper Raquel's house,
Oh, that's really.
which was very,
Was that fun for you?
it was fun because I had to be the one that got out and like took the picture of her crazy car over the fence. Yeah, because my kids were like, I'm not doing it. So I was like, it's okay.
Well, it's so nice of you for doing that.
Yeah, well, I was like, you know what? I'll take one for the team. You know?
That was really nice.
But yeah, no, so we do fun stuff. But what was my point in that story?
California.
Oh, you know, when I go, was one time when I stayed, we stayed at the Hotel Coronado. And there was like the York suite or the York hallway. So I took a picture and I sent it to her. So yeah, so it's very cute.
You guys are such.
Yeah, we were friends since North Shore, so
You were both.
yeah.
And you both came here around.
She was here and then it was an opening and then she asked me, and I was like, oh, I'll do it. So yeah, I've known her since forever. Yeah.
That's so.
Yeah.
cute. This one crosses out also.
Okay, what do you mean? Like it works out nicely? Is that,
Yeah.
okay, that's good. Usually they do. That's
So
the,
nice.
that's the whole point. The U-Substitution is usually pretty seamless. Then there are some other things that can happen, but we'll show you those.
No. they're not
Okay.
gonna- Don't worry.
They're gonna happen. All right, let's
Oh.
change the color here. So what do we let you
Wait,
be?
wait, wait,
Oh,
hold on,
okay,
yeah.
still working, still working.
You're still working.
Okay, everyone's good? Okay, all right, so what'd you let you be?
My year was 2x.
Okay, does everyone agree? Okay, so du equals 4x dx. So 4 du equals x dx. Okay, so then the x dx, you see here, becomes the du. Yeah. So it's the integral of du. I'm gonna pull out the 1/4. And then it's u to the 1/3. Good.
I rewrote mine a little bit.
You what?
I rewrote mine a little bit.
Right. So if you want to rewrite it as the integral 1/4 u to the negative 1/3,
Yeah.
do you?
I have the 1/4.
Inside, right. So then it becomes 1/4 u to the, because you add a 1. So then it becomes 2/3. Okay, multiply by 3/2. Plus the c.
Yeah.
So 3/8 u to the 2/3 plus c. Should have just replaced it while I was there. But our u was what was our u, 2x minus? That's 1, 2x squared minus 1. Okay. So 2x squared minus 1 to the 2/3 plus. Good? Okay, so let's do a trigonometry
Wait.
one. Okay. Yeah.
This one's so full.
You also make sure you print it out like into the next section. Right, I think the next section ended. Yeah, it's a couple of these, but if you need an extension on it, it's on, it's yeah, it's on Schoology, yeah. Just let me know in the mall.
It depends on if I can put it away when I get home.
Okay,
Honestly.
yeah, that's important. Important.
Well, it was possible.
Okay, so just let me know when you're ready.
I am ready.
Ready? Abby, Talia, ready? Okay, so let's try number 13. So 13, I forget the trig. I'm wasting your time here. Okay. So again, like, this is where possibly it could get confusing. Like, do I have the u be sine x? Do I have the u be cosine x? Right? So if you have the u be sine x, the derivative is.
Can I say that again?
It's like, in other words, sometimes people have an issue, like, do I let my u be sine x? Do I let my u be cosine x? If you let u be sine x, your derivative would be cosine x. If you let u be cosine x, right, which wouldn't help because that's cubed, right? You still have other stuff there, right? So typically, again, it's, so you could think of this as, if you rewrite this as sine x cubed, right? That may like kind of help you to like know which one to replace. But like right away, like you don't want to make u equal to cosine x because then what happens with this 3? Like you account for one sign, but then you still have 2 signs left over. Right? Because it's on cubes. Okay. That makes sense?
Yep.
Well, no, you could try it. Like if you let u equal cosine x, and then du would equal negative sine x dx, then when you go over here and you're like, oh, it's negative, I'm still gonna have sine squared x, right, left. And then my 1 sine x dx is gonna become du. Cosine x is gonna become u, and I'm still gonna be left with a mess.
Right.
Right, so you don't wanna do that. If you're left with a
Right, if
mess,
I looked at it, I would just pick one of them, and then if it didn't work, I would just pick the other.
again, like when you start, yeah, that's probably sometimes what you'll be doing, but again, you should try to pick the one that's inside this function here, something like the parent function, right?
Yeah.
Like it's cubes or it's to 3/2, or like we see that most of the time, that's the one that will help us. But again, don't put this, the cube part as your u. Because that makes it more complicated as well.
Oh, but the derivative of sine x cubed is so.
That's what I'm saying, you only make it sine x. Because you're right, if you do sine x cubed, then it becomes even worse, right? It becomes even worse. Yeah, so again, when you're first learning these, like sometimes you have to like kind of play around with it to see what works better than something else. Okay, so then du would be equal to cosine x. Okay, so there, that's gonna be replaced. Uh-oh. Okay, go. Let's pick blue this time. So now you have the integral of u cubed, and all of this is du. And that, like, look how nicely that works. Like happy, right? It makes you so happy, right?
So happy. The most happy. No, it is actually pretty good.
Right, you kind of like, you feel like, all right, I went somewhere with this one. And then you get what?
And then you get fun. What am I saying?
Oh, it was, well, you had u to the 4th over 4, right? Plus c. Hello, I'm recording it for you.
Thank you so much.
Yeah.
Well, Indy actually did this her.
Oh, yeah, so wait, she wasn't in the,
She didn't go to open office, but she took the final.
no, but she didn't go to the lab thing.
She did.
She's in the lab thing also. Okay, that's what I was trying to.
us.
Right, that's what I figured. Okay, okay. Okay,
But you already did use substitution, right?
Yeah.
We're in the middle.
Ah,
yeah. So, right, you'll get the tail end.
I printed out too.
Oh, okay.
Not all your pens in there.
Remind it.
Okay, so then over here, so what do we say, Talia? It was 1/4 sine x to the 4th.
I did it differently, but
Plus.
Good. Or you could just do sine to the 4th x, yeah? Right, you could, yeah, okay,
But I just did sine x to the 4th over 4.
that's fine. Which way did you do?
I did it differently. I want to see.
You got to see this.
No, because I couldn't want to look outside.
Okay, you want what?
So right now, we were just doing page 160, number 13. So we're already in the trig, so definitely go back to the other ones I did earlier, so you can get the whole idea. So like, but the thing is that I think you'll get the idea from the next one we do.
Okay, what did we do today?
We did more U-Substitution, so you'll be caught up then. So then I think that you should watch it again.
I might watch this new video. when I get home.
Okay, that's fine.
This one,
Yeah.
straight away, you found it, was this, which is already part of the equation, so just sub it in right away without.
So it's not technical.
Yeah.
So what happened over there?
Because for the other ones,
I'll
we
show
took from, like, from du, we found what dx equals, but you don't need to for this one because you already have cosine x dx in the equation.
Is du, right, is du. Right, our whole
Yeah.
point is
I
though
feel
to
like
get,
Tuesdays.
oh, and you can't pull this out.
Tuesday was my favorite day.
Remember, you
Yeah.
can't pull out
Yeah.
of the very, yeah, and then again, you
Yeah,
don't
I
have.
have.
Yeah.
Sense? All right,
It's a good day.
all right, so now let's do another one, okay, but now again, you have to remember all your.
Is there homework?
Yeah, it's only three, if you need an extension, it's only 3 problems, but whatever, no, it's actually more, a little bit more. Yeah. No, it's not. Okay.
As Sarah's upstairs, or you.
I thought it was been too central, you guys. They do quality.
Okay, so here we go.
Like the school organizes college visits for them.
Yeah,
It's so.
I think you know.
So this one you have to obviously know your trig integrals.
Oh, my gosh, yeah.
Oh, yeah.
Oh, we get to see our map.
Yes, I asked her.
You have to come during your free period.
During these.
Was there a big curve?
Yes.
I just use the same curve as the other.
There's
Really?
Yeah.
I mean, luckily did have that, but.
That's giving like partial credit, like, I mean, again, like, you know,
Really nice.
Choice did you get partial?
yeah,
Okay.
only because there were a lot of points each, yeah, there were a lot of points
Wait,
each.
but should we get to see you together?
I don't know, some people said they were coming during 6th, but,
Yeah, one, yeah.
right, but I have the first, let me fish them out, because they're right now,
I'm very, she said to get your Mrs. Top stuff first and then. you-
right, because I also want to eat, you know.
Which makes sense. I
It's
get
like
it.
it's like
I
a-
do too.
Right, right, yeah, right,
And this
5th right now.
is test. This was our free period.
Yeah.
that we were with
Okay.
them.
All right.
This is a meeting.
There's 2 more minutes.
Really?
Yeah.
Oh, okay, so we didn't get to the mean one yet,
I thought this was.
Well,
the
the
meeting.
No, this
mean
wasn't the
one,
mean
There's a
one.
picture of a different mean one, 23, which is descending because you got the equal x. Dx.
I don't know which one to make the U.
Well, again, you have to think of
I'm
your,
thinking tangent is secant squared,
okay,
and
But-
secant is tangent secant. Yeah,
okay.
so I don't know.
So you're saying so the integral of tangent secant is what?
Integral of tangents.
Okay, so that tells you something, right? Because,
That doesn't. It
No, no,
tells you
because-
something, but
well,
it's not telling. you.
okay, so the, well, because if you just said the integral of tangent x secant x
It's secant,
is secant x plus c,
right?
right? Then you have tangent x secant x, except you have a 10 in here.
It's true.
So then what do you think you want to let your u be? You don't want the tangent, you want the tangent of x secant of x. Or you want the tangent of u secant of u.
For U 10x.
Yeah,
Oh,
yeah.
Oh, I
See, I never thought to do that.
Anyway, but now you will, Again, it takes, you can because it's attached to the x.
Oh, right.
That
you
would be
can't
like
pull out
math
variable.
jail,
Right.
jailbreak.
Someone get me out.
Yeah,
Thank you.
yeah, math jail. Okay.
makes me so happy.
What?
And every day I.
What made you happy?
Food.
Food, okay, good. Food, that's good. I mean, if you said math, that would be a extra
I just look
credit.
forward to my next.
I mean,
I
you
love
just
that.
missed-
I love that. It's my favorite part of the day.
missed out on extra credit.
I was crying.
No, I said
today.
math would have scored you some extra credit.
Well,
If you
I
said it
love
all.
that.
Like,
See?
actually, no, like, actually.
I
Really?
didn't actually
Because she
cry,
loves
but
it.
I
You cried
cried,
internally,
right?
right? You
Because-
cried, you
yeah.
thought about,
Because I don't cry.
right,
so,
right. That's
yeah.
okay.
Yeah.
Okay.
No, I was legit.
Okay, so let's quickly before you have to go to the shop. Okay, so, what's du?
10.
10.
No, 10 dx.
Right, so that means a 10th
X.
du equals
Yes.
dx. Okay, so I'm gonna take out the
I can
10,
do that. That's what I can.
and I get the integral of tangent u secant u
Oh, this is.
du.
Ah.
Yeah,
My,
Oh, and then you just take.
oh, never mind.
And
right,
then can you seek me, you would seek me. Right?
right, so, it's 1/10,
Yeah. Let's see.
yeah,
Oh.
secant u, and u is 10x plus c.
Well, see, once you tell me half of it, I can go around.
Well, again, you'll get to the point where I don't have to tell you only a fourth maybe. Do you want to do you have time for the mean one? Not the mean one, it's just the more challenging one.
Let's do it, it's worth it.
Let's
I don't agree.
do it.
Oh
Oh gosh, I know, well, you know, that's how I keep myself entertained. Okay, all right, so what I try.
Is it 18?
17 or 18, yeah. Let's do 17.
looks harder.
Okay,
Because
So-
fractions scare me.
Because 18 you do the thing where it equals the x squared. I don't know. You're not that big.
okay, so.
You teach a class.
Do I teach a class?
You probably do.
Oh, I
because it's not on
do.
Your extra house.
Oh, no,
It's
you
experience.
Wait, hold on a second, do I teach?
You know, I don't even know why I don't know the schedule.
Okay, so
let's
let's
change it.
Let's
Yeah,
go.
one of the class coming in.
Let's just do it fast. They're late anyway. You.
They're waiting, they're waiting.
Oh, no, I missed
Okay.
it.
It's fine. So then you can't come to me right now because I have class? Okay, Thursday, perfect. So here, if you made this U or if you made this U, I feel like I don't want to rush through this.
I need X minus
So
4
what should
here.
we do?
Well, we'll just do it tomorrow. Like we'll do one of these, one more tomorrow in class, yeah.
I did U is X minus 4. I mean, U is X minus.
So, right, let me give you a little hint. If U is X minus
Is
4,
that right?
then X is U plus 4.
Ah,
Oh, this is literally, this is like 23.
so then
Right.
you just put it X plus, oh, got it.
Right.
Oh.
And this would go in here and you get everything in terms of U's. It's just a little bit more creative.
Tomorrow.
Yeah, it's a little bit more creative. Okay,
Thank you so
No
much for the concept.
problem. Let me just stop the recording and then I'll send it, okay? Okay.